Hello everyone. So today I'm going to talk about the harmonic series and why it diverges. So the harmonic series is defined like this. So it's an infinite sum of 1 over n for n from 1 to infinity. So it can also be written explicitly like this. And so I'm going to prove that it diverges, and I'm not going to use any advanced theorems for this. So because there are some advanced tests for when a series converges and when it diverges, but I'm going to show a simple proof that doesn't use any of this. So let's rewrite, not rewrite, but let's group the terms in this sum. So we take the first term by itself, the second term also by itself, then we take the group of the next two, then we take the group of the next four. So let me write them. So it will be 1 over 5 plus 1 over 6 plus 1 over 7 plus 1 over 8. So we group this together. Then we group the next 8 terms. So it would be 1 over 9 plus 1 over 10 and so on. So it would be a group of the next 10, then the group of the next 16 and so on. So here we have 2 terms, here we have 4 terms, here we have 8 terms, here we would have 16 terms, and so on. So now let's estimate the sum in each of these groups. So the first two are kind of special. Well, the first one is special. So we would bound this sum from below. So we write that it's greater than or equal than. So the first term is a special case, just one. So the second term we leave as it is. So it's 1 over 2. So then in the next group of 2 terms, we notice, like, we replace all of them with the smallest of them, which is the last one. So basically we replace 1/3 with 1/4, and 1/4 we leave it as it is. So it's greater or equal than 2 multiplied by 1/4. Okay, so there are 2 terms in this group, and each of them is greater or equal than the smallest one of them, 1/4. Okay, so in the next group there are 4 terms in the group, and each of them is greater or equal than the smallest one, which is 1/8. Then in the next group there are 8 terms, and all of them are greater or equal than the smallest one, which is 1 over 16. And so on. So the next one would be 16 terms. Each one is greater or equal than 1 over 32. 32. And so on. And notice now that write that this is equal. So 1 plus, and just for consistency in this term we can write 1 multiplied by 1 over 2. So the second term would be, so this would be equal to 1 over 2. The third one, so this is equal to also 1 over 2, right? Then this one is also equal to 1 over 2. This one is also 1 over 2. And so on. So we see that so we bounded this sum from below with this sum, which is obviously divergent. So like this is basically 1 plus sum of 1 over 2 from 1 to infinity. So this is divergent. And that basically concludes the proof.